camera. I'm standing over here. Yeah, there. Okay. Let's talk about that. I always do this at the beginning. And so at the beginning of, when you check YouTubes, you know, when is something, and you can always take a picture of it if you want, but I put the calendar over here so you know where we're at, what we're doing, when we're doing it. Homework is due, speaking of homework, homework is due the day we take our test. Now, when is that going to be? I don't know yet, because I'm not going to say the test right here, we're going to do 1.7 and then we're done. So the test is like the next day. No. If I have to take an extra day to finish a concept, I do. I'm going to say something that kind of caused a little ruckus yesterday in the Tuesday, Thursday class. I haven't taught Math 3A yet. I don't have the pasting down yet. I have taught all of the content, but I haven't taught this course. Okay. When I said I hadn't taught Math 3A, you're like, oh, that's cool. I heard that. That's good. That's popular. Listen, it's just college algebra. Got it down. No worries. Got on record. No. Hold that against me. But the deal is that my philosophy is, if I say the test is on the 31st, and I haven't finished lecturing on the whole chapter, it's not fair to you guys to put, 1.6 or 1.7 on the test if I haven't lectured on it, or giving you a chance to review it, or giving you a chance to ask questions. So move it. Does it bite me sometimes? Yeah. It's like going to the buffet, and this is why I can't go to a buffet. I can't get my money's worth out of a buffet. I get full too fast. I know it doesn't look like it, but I get full too fast. I got friends who are thin and they eat for thin. Okay, that's just the evil cruelty of the universe to me, because I get bloated and full and I can't eat anymore, and I spend $37 wherever it is, or $25, or whether it's hometown buffet, only for Holy, or if it's someplace in Vegas. I get full. Put too much on your plate and your eyes are bigger than your stomach. Okay. So I move things if I need to. Okay. This is the actual homework. This is also posted in the announcements. I told you I was going to print this out because last week I forgot to actually have it printed. But that's the copy. And as you can see, all of the assignment is there. The numbers to do, and so on and so forth. And remember, you are grading your own homework, and then I grade how well you graded your homework. And you turn that in as the cover sheet stapled on the top the day we take the test. Now, good, from hearing from you, you guys are already working and doing 1.1. So when we, today I'm going to finish up 1.1. Next Monday is your chance to ask questions on it. So you don't want to wait until the day before the test to do all the homework. You want to finish it the day we work on it so you can ask questions on it the next day, because we're not going to come back to 1.1 when we're doing 1.3, 1.4 to ask questions about 1.1. That means you got to go to tutoring or office hours. Okay. All right. So continue 1.1. We did start a little bit talking about functions. Begin 1.2 if we can. Yesterday I did with them, but now they are a day ahead of you because they meet twice this week. You guys are on week one, and out doesn't matter. Monday 1, 2, and 1, 3. Wednesday, the last day of January. Past day of January already. Okay, 1, 5, and 1, 6. You can see 1, 5 overlaps a little bit. And we're going to take a quiz on 1, 2, 1, 3 on that last day of January. Okay. No stress, and I don't want anybody, because we only have right now 4. The last day of drop is 28th, Friday the 28th. Hang in here. Okay. All right. You know, I had a really nice head of hair growing up. And then when my daughter was born, it slowly started falling away. Well, honestly, I got married. Well, no, seriously. Food, dog pictures, cat pictures, whatever. You know, that is.
You see that guy who?
No, that's not Stephen Hawking. That is John Wooden. John Wooden was the coach of UCLA Bruins basketball. Won, I believe it was 11 or 10 national championships. He is, well, he coached Primo Gold, James Worthy. Okay. He's the winningest basketball coach in, well, whether it's a winningest percentage or total number of wins, he's just a humble man from, I believe it is Indiana, I want to say. And well, the reason why I'm showing it is my head of hair. Okay, anyway. But I got to meet him at a basketball clinic, like I think it was 1991. Or actually, that was 94. Not that that matters. But until I started teaching online and doing the videos, and I would watch these videos, and I turn around and I'm working on the board, and I see the back of my head. Well, who's that? Because you never see the back of your head. When I get my hair cut, they used to hand you the mirror so that you could look and see how they cut it in the back, or they could do it. They don't do that anymore, at least not with me. Who's that guy? Where's my hair? Because when I brush my hair in the morning, it's like, okay, it doesn't look too bad. It doesn't, you know, I know it's thin, but I'm walking my dog down the aisle. There's a point where I've got my head down a little bit and I'm looking at her, and all I see, I'm like, yes, I know I should be looking at my daughter and me in the picture and how great, but all I see is this, looks like this bad cold. Man, it's depressing. You, hopefully, you guys, I don't know. What's your grandfather? There, okay. That means you should, because it's what about your dad? Well, then maybe you got the right genes. Usually it skips a generation. I don't know. My dad had no hair. I don't know. I'm so young compared to everybody else. My dad and my grandparents. I didn't even know my grandparents because they died before my dad's parents. My mom's parents died when I was like 5. Didn't really know. I have no idea if they had hair or not. Even pictures you can't really tell because they're wrinkly old black and whites. So I don't know.
You're the youngest one.
I'm the youngest, and I was, you know, my mom was 45, my dad was 50. So my dad was born in 1917, fought World War II. One of the first in the Army Air Force. The crazy thing about my family is my grandfather, my mom's dad, came to America, was pure Mexican. He just, he would don't know English in his house. On Mexican Revolution Day, he would have the flag out, drink all day long, and just, you know, it was just, his heart was Mexican. All of his sons enlisted and fought in World War II, or what, and one went to, the others went to Korea. They all went overseas. They all lived. That was the crazy thing. They all survived. You know, you hear, you see Private Ryan, you see all these war movies and how many people died. When you go overseas, out of all those 1, 2, 3, 4 boys, they all survived. Okay? And when growing up, all of my aunts and uncles spoke really good English. I couldn't really tell there was an accent, even though no English in their house when they grew up. And that's that real cool stuff on that. Okay, so we did these, talk about what these all look like. And eventually they're going to grow. You can see what sections are popping up in. So we're not going to really do parabolas really until we get to section 3.1. We're not going to do x cubes, polynomials, so the polynomials are not going to happen until chapter 3. Rational, not until 3.6. Square roots, we're going to talk about in 1.3. These are algebraic functions. And this is just language. This is just, I want to make sure that you guys process this and you hear it. Are formed by applying algebraic operations to a simple f of x equals a single x. So when you apply an algebraic operation to this, you square it, algebraic function. Cube it, that's an algebraic function. 1 over x, you divide by x, that's an algebraic function. Take square root, that's an algebraic function. So powers, exponents, to the 1/2 power, third to the second. This is x to the -1. Remember that. X to the -1, we have a negative exponent, it's a reciprocal. So technically, these are all x to the n powers. Powers of x. Algebraic functions. Transcendental functions. Love that name, transcendental. So these functions cannot be formed from a linear function. So you can't form it with just an x. Okay, by using an algebraic equation. We need a different kind of equation, different kind of function. A to the x. So now x is the exponent and a number is the base. And there are some set rules about what a can be. And that's not until chapter 4, exponential functions. Logarithms. Now, these two go with each other. As you can see, they're both in chapter 4. The inverse function that undoes an exponential function, a to the x, is a logarithm base a. That's the one thing that nobody ever made clear to me until I actually have started teaching this stuff is, every time we learn how to do something in math, I'm sure it goes the right way, left to right. Every time we learn how to go do something, the next step is we learn how to undo it. Your entire life, you learn how to add, you learn how to subtract, you learn how to multiply, you learn how to divide. Every time. You learn how to square something, you learn how to take square root of something. Cube it, cube root. You learn how to raise a to the x. How do you undo a to the x? Here comes the reason why we have logarithms, to undo a to the x. You learn how to take the sine of an x value, sine of an x, sine of an angle. We need to undo the sine of an angle. You take the inverse sine or arc sine. That's the inverse sine. Okay, you plug an angle in and take the sine of it. Sine of 30 degrees is 1/2. And then you take the arc sine of 1/2 and it spits out 30 degrees. It undoes what the sine did. So these are the inverse trig functions for these three. These are the reciprocal trig functions for those three. The reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. Have you heard of SOHCAHTOA? Sorry, I'm saying it backwards. So Patoa, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent in a right triangle. That's how you know what side to put over what side to make those trig functions. Here comes Choshakao, so Patoa's older brother. And all that does is just flip the letters because it's just reciprocal. Why don't we have the inverse for these? You don't need the inverse for these because this will take care of those. It's all about manipulation. When you get to trig, you learn how to manipulate what you have to get what you want. Now, that doesn't happen in this class because it's trig, it's math 4A. And that was a point I brought up yesterday. I haven't taught math 3A, but technically I have taught math 3A. We used to call it math 4B. You take 4A, then you take 4B. We realized you don't need to take 4A, then 4B. You could take 4A, then, or you could take 4A, then 4B, you could take 4B, then 4A. You can take 4A and 4B at the same time. I have students that are taking 3A and 4A right now, at the same time. Okay, you don't need to have one before the other. Unfortunately, because it's a number system, it seems like you gotta have 3 before 4. No. You don't need stuff from 3 to do 4, and you don't need stuff from 4 to do 3. Okay. And math 4 is all trig. And then we get to the non-elementary functions. And you're going to see these in this chapter, chapter 1. Absolute value. The absolute value of a function. Absolute value. You can't spell value without a V. The shape of an absolute value function is a V shape. On the graph. Okay, and go here. Simpler one. I don't need the 18 by 18. And I want to pull this up to kind of, this is on page 70 again. 75. It's just at the bottom. Sketching the graph of a function by point plot. When we first learned how to graph any kind of function, the very beginning. You pick numbers and you plug them in. You pick a number, you plug it in. Pick a number, you plug it in. And then you realize that it's always going to be a certain shape. So you try to make a generalization. And the goal is to never have to pick numbers anymore. To start recognizing when it looks like x squared, it's up or out. When it's x to the first and y to the first, it's a straight line. Now, notice that we're going to be looking for, if it's a straight line, what's the slope and the y-intercept? If we can find those things, we don't have to plug in numbers. We just plot and count. That's it. If possible, rewrite the equation so we have one variable isolated on one side of the equation. Solve for y. What does y equal? Or solve for x just in case. You'll see that we do have to do that. Make a table of values because that's how we get started. When we don't know something for the first time, make a table of values. Plot your answers on a coordinate system, x and y axis. And then connect the points with a smooth curve or a line. It depends. If you take a stats class, stats is all about collecting data. You collect data and you want to find a correlation between a couple of things. So a lot of times the points are all scattered. Then they use something called regression formulas. And you can find a linear regression, a square regression, a cubic regression, and they will find the calculator, the tool, the technology. Statisticians, they really don't want it themselves. They use calculators to do it or technology. But what they want to do is they want to come up with an equation so they can plug in any value and predict what's going to happen maybe in the future. So the calculator will find the best x squared curve that will fit all that data, or the best x cubed, the best x curve, whatever the data starts to resemble. Okay. All right. So this with f of x equals just absolute value of x. You would just start with this. Absolute value of x. So table x, f of x equals the absolute value of x, and I'm going to plug in -3, -2, -1, 0, 1, 2, and 3. So when I plug in -3, we get f of -3. I take the absolute value of it. The absolute value of -3 makes it a positive. This absolute value means distance from 0. How far away from 0 is -3? It's 3 units away. Distance is always positive. And we know that because when Ferris Bueller tried to run that Ferrari backwards and try to take the miles off, it didn't work. Okay? Nobody cares. So x is -3, ordered pair, and the y value is positive. So at -3, we get positive. And then f of -2 is equal to the absolute value of -2, and that's going to give you positive. So when -2 goes in for x, the function equals +2, and that's our y value. So -2 goes in, +2 comes out. F of -1 is the absolute value of -1, which is +1. So we get -1, +1. And you can see that those are straight. That makes a nice straight line. It's going from this corner to that corner to that corner. Up one, left, up one, left, up one, left. It's going to, now you start to see a pattern. Let's see if it keeps going. F is 0. The absolute value from 0 is 0. So yes, or down 1 to the right, down 1 to the right. When you guys graph on tests and quizzes, I want, it's the direction goes to say plot and label. Label. Because if you label, then I know you are in the right place and you're paying attention to what you're doing. And I'm trying to help you learn how to present, because when you get into the real world, and let's say you're turning in a project, if you don't have things in a certain way with specs or whatever it is that you might be doing with detail and pay attention to the details, you don't get the contract, you don't get the job. You look foolish. So take pride in what you do. That's all. What I do ask is, when you're at the origin, it just gets a little messy. I don't care if you label the origin or not, but it's just a little messy. Right? That's all. When it's out in the quadrants, yeah, label it with the ordinals. So if all you do is think it's going to continue the pattern, down one right, down one right, down one right, it will keep going like this. So let's see. F of +1, the absolute value of +1 is +1. So when 1 goes in, 1 comes out. When 1 goes in, 1 comes out. 1, 1. So it doesn't keep the pattern going. And f of 2 is the value of 2 is equal to 2. Now here. And now you can probably see the pattern that it's now going to go in the other direction straight up. But that's what an absolute value does. It would have kept going if it was just x, because that's a linear equation. Okay. And when x is -3, well, technically it would have been going this way. So if you had that, then it would have been going this way. Because the slope would be a negative. But when you put an absolute value, all the negative answers are going to reflect across the x-axis. And then one more thing that I asked you is that when you graph something that is a straight line, just take out an ID card, credit card, driver's license, something with a straight edge. And you draw this thing nice and straight. We got arrows on this because it's going to go forever left and right. If you don't put arrows in, it looks like you stop. But as you can see, an absolute value is a V shape. Every time, all the time. And the reason why we call this non-elementary. Some useful non-elementary functions is because, again, an algebraic function, you apply an algebraic operation to x. Absolute value is not an algebraic function. What it is, it's a piecewise function when you define it. When we define an absolute value to math students, there's 3 phases we take students through. Little kid phase, high school phase, junior high school phase, and you're going to get the actual definition of absolute value in this class. When you're a little kid, we tell you, if you put something inside the absolute value, it comes out positive. Just make it positive. We don't tell you why, we just make it positive. You put a negative, make it positive. You put a positive, it comes out positive. Whatever you put in there, make it positive. That's all. That messes kids up when you put in absolute value of x minus 2. Because they think it's just going to become x plus 2. But with the little kids, we don't give them x. But when you get to algebra, that's what they want to do. When you get to algebra, we say, all right, it's distance from 0. It's distance from 0. So what you have to do when you have something like this, if let's say you had the distance from 0 was a 5. So here's the deal. Behind my hand, this x minus 2, the absolute value of 5, if it was a 5 inside here, then that would work. So the x minus 2 could equal a 5. What's inside could be a 5, and that would equal a 5. Or the absolute value of a negative 5. The absolute value of a negative 5 could come out of 5. So this x minus 2 could equal a negative 5. So what I did was I don't change what this looks like. It's x minus 2, it's x minus 2. But when I break it down into 2 equations so I can solve this, I tell my students, you're first going to rewrite this as is, exactly as you see it. 5 and x minus 2. Don't change anything. And then you're going to write it as opposite. Because what's opposite? Because what's inside the x minus 2 could equal the opposite of this other number. So you do it as is and then as opposite. You solve each one. Plus 2. So this x could be a 7. You add 2. This x could be a negative 3. 7 minus 2 is positive 5, absolute value 5. Negative 3 minus 2 is negative 5, absolute value 5. And that's how you separate it so you can solve it. 2 equations, because it's distance from 0. Now what happened was x minus 2, distance from 0, 0 is right here. The x minus 2 moved it to here. That's where x minus 2 lives. So if we're looking at 5, the x would have to be here at negative 3, or it would have to be here at a 7. Negative 3 minus 2 takes you to here. 7 minus 2, that's 5 units away. Minus 2 moved it to the right. Minus 2 moves it to the right. If it was x plus 2, exactly, because now I subtract, that would be 3. That would be negative 7. And we would be here instead. X plus 2. This would be negative 7 for the x, because that's 5 units away. And over here, that 3 would be my 5 units away. If you see plus 2, then the x that normally starts off at 0, if it was just absolute value of x, right here at 0, when we have x plus 2, it goes this way. And when it's x minus 2, it goes that way. Because in 1.3, it should be going here. And the class before you take this, Math 103, this is what we do. We do study absolute value. And we study it like this. A, absolute value, x minus h plus k. That's the complete equation, the standard equation, standard function form for an absolute value. Now remember, I told you, it's all about graphing and not having to plug in any more numbers. I know it's a V shape because it's absolute value. I'm going to know what A does. Right now, I'll just tell you, if I put a negative in front of that absolute value, if I put a negative, use red. If I put a negative here, that means there's a negative on the outside. You take the absolute value of negative 3, yeah, you get positive 3, but waiting out in front is an extra negative. So the actual answer is going to be a negative 3. My final answer doesn't matter at negative 0, 0. It doesn't matter that you're taking the absolute value, because that negative is going to make whatever happens into a negative answer. So all of these positive numbers, that's a 3, 3, they're going to be down here. Because negative 1 now gives you negative 1, negative 2 now gives you negative 2, 1 now gives you negative 1, 2 gives you negative 2. If the A is negative, everything flips upside down. And that is true on every function, no matter what we graph. If a coefficient is added to your f of x, it takes your regular positive f of x, and if you make this a negative in front, it reflects it across the x-axis. We're not going to deal in 1.1 or 1.2. We're not dealing with reflections or transformations yet. Well, this won't come, but that's A's job. H, you see how H is locked in battle with x because it's right in there in the function with x? H is the horizontal shift of the graph. It moves it left and right. Do you see that negative in the formula? These are all general formulas. Whoops, my bad. A times B to the x minus H is always there with the x, the alphabetical, H and K, X and Y. H before K, alphabetical, right? So H goes with X. It's the horizontal shift that moves it left and right. That means K is the vertical shift. K moves it up and down. The negative is built in. That's why right here, when you see X plus 2 and it moves it to the left, because in here, H is a negative 2. The only way to get this to come out to be a plus 2, the formula would be X minus H. So this has to be, to get a plus, X minus a negative 2. That's what the H would have to be in order to get a plus 2. It would have to be a negative 2 to make this a plus. In other words, remember, everything is centered at 0. What would you have to plug in to make that a 0? Negative 2. That's what would take you back to 0. So that's the shift, left and right. When you see this one, where do I put it? X minus 2. Then this is in disguise X minus an H. The negative is built in. So what are we subtracting from H? We are subtracting a positive 2, because that's the only way it stays negative. This would be X minus parentheses a positive 2. So H is a positive 2. That's how you get X minus 2. You subtract a positive. The negative is built in. The negative is built in on the H all the time. Now, this is how I help my math 103 students. Try to remember. Not all of them always do, but I will speak it this way. When you extract the H because you want to know what the shift is, H, you're going to do the opposite of what you see. You see X plus 5, the shift is negative 5. You see X minus 3, the shift is positive 3. When you take out the H, it's got a negative in front, you're going to do the opposite. So you're going to do for H, the opposite for H. Do the opposite. Okay. K has got a plus in front of it. So you keep the sign for K. If you see plus 3, K is a positive 3, everything shifts up 3. If you see minus 4, then K is a negative 4, because if it's plus, it's going to keep the sign. But when you have a negative, then what you just plugged in and what you end up with is opposite of what you plugged in. X minus a negative 2 means X plus 2, you plug in negative. Okay. And that is going to handle what we're going to be doing with the horizontal shifts and the vertical shifts. Okay. And that other one, and this one's kind of fun, is the greatest integer function, 1.4. We're going to get to homework examples in a little bit, but I want to show you right off the bat graphing calculator stuff. So I'm going to show you. From the homework. Right. Nope. Number 55. So I'm going to show you how to use the graphing calculator. Every now and then, because I'm not doing it enough, make sure somebody glances at that screen to make sure I'm getting everything. If I pull back so far, I don't know if it's clear enough when you're watching it from way back when it's, you got too much. So I try to zoom in, but if somebody glance over there and saying, you can't see the other part of it. Also, I don't know if you've watched any of the stuff I posted last week. I tried to watch just a little bit of it, and you can't really hear me clearly. And it's because that thing's on, that little blower, okay? So that's why I'm turning it off. So. Make sure you stay healthy because people are catching. Even vaccinated people are coming down with COVID, and they're not as bad, but they're catching. Okay. In exercise 55, 58, solve for y and use a graphing utility to graph each of the resulting equations in the same viewing window. Adjust the viewing window so that the circle appears circular. These are not functions in terms of pure functions because you have x squared and y squared. You can't get just a single y by itself. They're conic sections, and that's another part of what we will end up studying this semester. But because x squared and y squared are both squares. It's going to be a circle. Because it's x squared, one x squared and one y squared. The number of the coefficient of the x squared and y squared are equal to each other. If they weren't equal, like one x squared and two y squared. So the ratio of x squared and y squared is not the same. Then that's how you get ellipses. Okay. If only one of them is squared, x is squared, but y isn't, it's a parabola. If y is squared and x isn't, then it's a parabola that goes sideways. If it's minus x squared minus y squared or y squared minus x squared, then it's hyperbola. And we call them conic sections. Conic for cone, section for slices. If you slice a cone, you can get all of these shapes. You can get a circle, you can get a parabola, you can get a hyperbola, you can get an ellipse, just depending upon what angle you slice the cone in. So when we get to conic sections, I will show you all this. But at some point, you're going to see that the equation of a circle, and guess what? It's going to look like this. X minus h squared plus y minus k squared equals r squared. That's the formal or standard equation for a circle. Copy. So H, messing with X. The negative is built in. It's sliding something left and right. K is now inside of parentheses, locked in there with Y. And there's a minus in there, so that means it's shifting the Y value up in there.
So they sometimes use a P.
They use all sorts of things. Okay, this is a general standard form when you're looking for the center. For the center of the circle, it's HK. It's just the order pair H and K. That's where the center of the circle is. The R is the radius. So if you know what that, if it's set up like that, you know exactly where the, like right here. R is a positive 3. Sorry, H is a positive 3. K is a positive 1. So the center would be a 3, 1. This is radius squared 25. Take the square root. So the radius would just be a 5. Okay. If you saw +1, you take out the opposite. Okay. Because it's x squared plus y squared, the only way to get this squared and this squared with nothing else in a parentheses, it would have been x minus 0 squared, and this would be y minus 0. Yeah, that's what your H and K, they have to be zeros because there's no parentheses. So that means the center of the circle is the origin. Okay. So, open up calc. Here's the deal. You cannot punch this up in a calculator. First of all, the only way you can type in a function on a calculator, I go to my equations.
You take the square root of 16, right?
Yeah, you take square root of both sides. The only way you can punch something into a calculator is you have to have y by itself. Now, let's walk you through something. First of all, modes. We got some modes to worry about. Modes. I'm going to click on mode and just a little rundown of things. You want to be in normal mode versus scientific notation versus engineering notation. I've never used the other. I've got a degree in math. I have a master's in math. I ain't ever used the other two. Okay. There's a gradient button. Well, this one, they even took gradients off of this, but under regular scientific calculators, you got radians, you got degrees, radians, and gradients. Degree in mathematics, I've never used gradients, but I do know what they mean. There's 90 degrees in a right angle, isn't it? Right? 90 degrees. When we learn how to measure angles with radians, we measure it in terms of the ratio of the radius and the arc length. Okay, so a circle is 2 pi radians. So a 90-degree angle is pi over 2 in radians. Just another way to measure it. In gradients, instead of 90 degrees, it's 100 gradients. So it's base 10. So 100, so instead of 90, 100, 200 for 180, 300, and then there's 400 gradients in a whole circle. That's they're called gradients. I was always told, since I can't remember when, that it was something the military used. Don't know. I've never been in the military. I don't know. Might be. But when I watch the movies, I never hear anybody say gradients. Down here, you need to be in function mode. Because if you're not in function mode, It's not going to graph like you want. So function mode, this is parametric. This is polar, and that is sequential or sequences. So when I'm in function mode, we get y values. Plug in something for y. Plug in equation in terms of what does y equal. Now watch, when I click over and change it to parametric. If I hit enter on parametric, you now have two equations. You have x sub 1 of t. You have x sub 1 in terms of t, y sub 1 in terms of t. So you have to input an equation for x and an equation for y with respect to time. It's going to plot x's and y's on the graph, but you have separate equations. What does x equal when t is equal to 3? What does y equal when t is equal to 3? That's a parametric equation. It also goes into vectors. When you go over one more, you go over to polar. Polar is now an equation that relates the radius of a function with respect to the angle that it makes with the origin of the xy axis. So it's r equals f of theta. So now you're plugging in something with theta instead. That's this button right here. This button has plug in x when you need to, plug in t when you want a function in terms of t if you're in parametric mode. When you're in polar mode, this is where you're going to find theta. And when you want sequentials, sequences, what is the minimum value of n? What is the function in terms of n? What is the formula for n times the minimum? Okay. I've never used that one. That's it. We want to be in function. That's what we do. And you want to be in connected, so it's not a scatter plot. We want, if we type in more than one equation, we want the graphs y sub 1 to graph, and then we want y sub 2 to graph. First one, then the second one. We don't want them to graph simultaneously. So if I click on this one, both graphs, if I have multiple equations here, they would graph all at the same time, and I wouldn't know which one was which. I want them sequential, so I know that the first one that's being drawn, that's my y sub 1. The next one, that's my y sub 2. And we're going to be using real numbers. That's complex numbers if we have imaginaries involved. And that would be complex numbers if we're dealing with polar equations. We want a full screen, not just half a screen. And I'm not exactly sure what that is. And the time zone. My calculator said. Now, as you can see, I can only type in an equation for y to the first, y equals. So I have to take this and solve for y. So to solve for y, I'm going to subtract x squared from both sides. So y squared is equal to 16 minus x squared. And then to get y squared, because I just want what y equals, you take the square root of both sides. The square root of y squared is just y. And right here, gotta remember something. Two things. We're solving an equation. Solve. When you solve an equation, if I gave you x squared equal 36, and we are solving. Anytime you're asked to solve, you're supposed to find all of the possible answers that work, everything that wouldn't work and make that true. So when you take the square root of both sides to solve this, you've got to remember plus minus a 6. Because positive 6 squared is 36, and parentheses negative 6 squared is also 36 when you're solving. If all you're doing is simplifying, what is the square root of 36? There's no equation. We're not solving, we're just simplifying. The answer is positive 6. Just the positive, or it's called a principal root, if you're simplifying. So since I'm solving, it would be positive negative square root 16 minus x squared. Now it's not going to let me plug in a plus minus. So that's where you have to input two equations. You're going to input the positive 16 minus x squared for your y sub 1, and for your y sub 2, the other one, negative square root 16 minus x squared. Second, square root 16 minus x squared. Close the parentheses. There's the first one. Now the next one. When you want negative 16 squared, 16 minus x squared, this is not the negative. That's minus. When you want negative, this is your negative. If you hit this, get minus and put it in front of the square root, you're going to get an error message. So you got to use that when you have a negative, just a negative in front of something. If it was like a 5 on the outside, and you had like y equals 5 minus square root 6, then you can go 5 minus and put a minus. But when you're leading with this and it's just negative this thing, then you put the little negative. So X is up here. Give me a second. Those are the and hit that. So now I'm going to go to there. And as you can see, my window is not big enough because it's not holding the whole thing. I'm seeing the whole circle. So the directions on the homework have some clues for us.
After the square root, did you put a space?
No.
We got the whole equation.
Oh, you have it. Okay. Okay, you're fine. Oh. So because yours does this, and you can actually input it under, you would actually not have to put the parentheses.
Okay.
So when I pull up mine, you see how it's just an itty bitty little radical, and then the parentheses isn't even underneath it.
Yeah.
I can't type underneath my radical. So therefore I have to put a parenthesis, but it pops up with a parentheses automatically. And then I square root of what? And I put in what I'm taking the square root of, and then I got to close it. Okay. Now what you have to remember is, because it pops up like this, y equals, and you get to just input underneath. So if we were doing y equals square root of x squared plus 1, and then plus 8 afterwards, plus 8 afterwards. So you would type in your x squared plus 1. Then you got to make sure you use the arrow because you got to get out from underneath. Because if you don't use the arrow, when you type in the +8, it's going to be under the radicals. Okay? That's what you got to make sure you do. Yours is going to be able to type it in exactly like it looks. Those parentheses are not going to hurt you. It's not going to hurt you inside. All right, this homework says, adjust the viewing window so that the circle appears circular. So first of all, I want to make sure I get the right window. So here's the deal. Remember what we said, x squared plus y squared equals 16. 16 is the square of the radius. So that means the radius of my circle should be 4. So what I'm going to do is I'm going to hit window, and that allows me to adjust the window. The x minimum, the x maximum. So the minimum value, this is negative 4.7. To the x maximum over here, the window is positive 4.7. The minimum on the y down here, it only goes down to negative 3.1. And the maximum is positive 3.1. Now, x scale, y scale. These are, these little notches. The x scale is 1, so that means this is positive 1, positive 2, positive 3, that's positive 4. If I tell it to be a 1/2 instead, then it would put 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. It would give me a notch every 1/2 of the unit. That's what that x scale and y scale means. So since y scale is 1, -1, -2, that's exactly -3. It gives you a notch so you have an idea of where you are. I need to make this, I want to make it -4 to +4. So I'm going to leave the scale as it is. And then -4 again to +4. Take breath. Okay, that does not look circular. That's a nice football shape. So if you were to, if that's what my calculator gave me, I hear that all the time, but that's what my calculator looked like. But you know it's a circle. It's not the scale, because look at the window itself is a rectangle that's longer than it is high. It's not a perfect square. Square. Now here's how you fix it. So you go to zoom. Zoom, zoom, zoom. And right here, option number 5. So you can either just hit 5 or you can scroll down to go to option number 5. Oops. And it will square up your window so you will get the exact shape of what you're supposedly graphing. So that is the exact shape. Now, I know. Yeah, it was more like a Pac-Man in a circle. I don't know what yours better calculator do. This is an older version of 4. Calculators don't like vertical very well. They don't like vertical because vertical means undefined because the slope is 0. Over here, it does a nice job of it. I don't know why it doesn't clean this up over here, but it's a complete circle over here. You just need to realize, okay, I'm drawing a circle, I should fix that. Now, I can do a zoom just to see what's going on over there. And I can do a zoom box, draw a little box around what I want to see. I can tell it what coordinate I want to zoom in at or zoom out. I can do a zoom decimal, and it will just do a certain decimal amount. Zoom square I already did, zoom standard, zoom trig, but I'm going to do zoom box. I'm going to not do long. So zoom box. So that means I have to move my cursor. I'm going to move it up to here, a little higher than that. Move it over where I want my box to be drawn. A little bit lower. And then I'm going to hit enter. And then my box is going to start to go down. And go to the right. And I want to see what's happening in that box right there. And I hit enter. And you can see that, okay, now my window zoomed in to a place where it's 3.2 to 4.51. And it's this tall. And you can see that they are approaching each other. Okay. And you can do it again and again, but you just start getting closer and closer, right? And that is actually something that one of the homework problems wants you to do, is do some zooming. You fall down the zooming rabbit hole when you start messing with things. You fall down the zooming rabbit hole, and it's sometimes it's fun because you can't stop. It's like when you're on a website and it makes you click on something else and something else, and so you're just down that rabbit hole. Wikipedia does it to me all the time. Start looking up bands, can't stop. All right, last little bit, ways to approach problems. 79. Mathematician, famous mathematician, I'm sure you've heard of him. Actually, I believe he's from Stanford. George Polio. Either Stanford or it was what's the Catholic University right next to Stanford? Not St. Mary's. Oh, I guess I can't. Anyway, George Polio is a Finnish mathematician who wrote many books in the 20th century about solving problems. Problem solving. That was his thing. One of his quotes. It's better, he didn't say it, he said, tis, or dramatic, tis better to solve one problem 5 different ways than to solve 5 different problems. Because when you solve one problem in 5 different ways, you're making your brain think it through from different perspectives. Your brain has to work overtime. Yeah, you can do 5 problems. What do you do? But can your brain look at it from different angles, different perspectives, different ideas? How original can you know? It's that dirty word, think. Okay? One of the things I have had to figure out as I teach is when somebody's not getting something, how can I say it differently from a different perspective that will help them learn? I had to figure out how to say the word opposite when I try to teach, horizontal and vertical lines. When it's a horizontal line, it's y equals a constant, y by itself. Horizontal is a lowercase h. So I tell them the y looks like an upside down lowercase h. That's the y value. Y equals a number, horizontal line. Put it together. I don't know how else to help you. Vertical line, x is by itself. Well, x is like a V on top of an upside down V, V for vertical. make a connection, do whatever you can to help you remember which one is which, because those are the easiest equations to write. If it goes to the point 5, 7 and it's vertical, x equals 5 is a vertical line. That's all you got to do. But you got to know some way to remember. Figure it out. An algebraic approach, rules of algebra. Does anybody know the formula for distance? Yeah, if you were doing like a work problem, you have to figure out, now I'm looking it up, just with distance. Formula you've probably been using for years and years and years. Distance equals. There's two other variables on the other side. Something times something. What? Distance? No. Because if I travel a distance, like if I travel a distance from here to Merced, length and width would not be, if I multiply length, which like say it's in feet, times another length, which is in feet, when I multiply the units together, I get feet squared. Distance would not be a feet squared. That would be an area. Length times width would be the area of a quadrilateral or some kind of line.
Time.
If time is involved, rate. Rate times time. Distance is equal to rate times time. Now, let me explain to you. You know this formula. You know it. You deal with it every single day. You know it. You just have to make the connection. When you drive or come to school or whatever, your speedometer gives you miles per hour. And that would be the speed that you're moving at, right? The speed. Miles is a distance. Hours is a time. Speed is your rate that you're moving at. You know that this happens every single day. So if you wanted the formula for what does the distance equal, multiply those sides by t. Distance equals rate times time.
You wanted time, you multiply by t.
Yeah, if you want a time, no, take it. This is good. If you want a time, so over here you see that if you divide by r, that's how you get time. It's distance divided by how fast you go. But if you start with this, distance over time is equal to rate, and you want to go straight to, I want to know what time equals, you got to realize something about this. Distance is in the numerator, okay? So to undo a numerator, you would have to divide. But over here, this is 1 over time is equal to rate divided by distance. I don't want 1 over time, I want time. So you could cross multiply and then continue, but you could just take the reciprocal of both sides. Reciprocal of 1 over time is time over 1, and that would be d over r. So time over 1 is distance over rate. And it's all about making sure that your units cancel out. If I want time, that means I want hours. So what I need is my distance. I want hours. This would be miles divided by this is miles divided by hours. So when you divide this divided by this, it's going to be miles times the reciprocal of this, because when you divide, you multiply by the reciprocal. So this would be hours over miles. And that's how you look at time. Algebraic approach. There's lots of formulas in your head that you don't realize are in them. That just makes sense. Okay. Graphical approach, draw and use a graph. Plot the data, see what happens. Numerical approach, construct and use a table. Sometimes seeing a pattern in the numbers will help. Hello, Fibonacci. Have you heard of the Fibonacci sequence? So the next number would be 13, and then 21, and then 34. You take the next number is the sum of the previous two. So you got to start with, you can't have one, and what's the next number? Well, the previous number don't know. So the next number would be 1, and then 1 was 1, 2, 2 plus 1, 3, 2 plus 2, 5, 3 plus 5, 8, so on. This number happens in nature all the time. Okay, it's in the sunflowers, it's in architecture, it's in the ratios, it's in production, you know, how species propagate. It's in my son's tattoo. My son's tattoo is a Fibonacci spiral. Right? I heard he told me he was going to get a tattoo. But yeah, it's a Fibonacci spiral. Okay. Leonardo da Fibonacci, year 1000. So now we're going to actually show you going through homework. So first off, right here, we have homework. And everybody has homework. Make sure I'm looking at one. And I'm doing this for a couple of reasons, to help you with some examples so you can do the homework. But number two, so you get an idea of what I'm going to expect from you. Okay, so 5 through 13, every other hour. Start with 5. They want to know, out of those points, A or B, decide whether each point lies on the graph, and that's just like A, yes or no, B, yes or no. In the cover sheet, I want to see, it says I want to see work when, appropriate work is needed. So that would mean I want to see the substitution. It's not that hard. Plug 0 in for X, plug 2 in for Y. So I would want to see 2 for the Y equals square root X is 0 plus 4. So does 2 equal square root 4? Happy face, yes. So A would be a yes. Get used to not always doing things in your head. Because when the time comes and you're not able to do it in your head, that's when students stop and they don't go any further, because the only method they've ever done in math won't work for them anymore, so they give up. Force yourself, because it's going to come. And then you try 12 and 4. If it works, yes. If it doesn't work, put no. Every other odd means you're going to do 5. You skip 7. The next one would be 9. You're going to plug 1 in for X, 2 in for Y, see if it works. Plug in the next one. 1, negative 1. 1 in for X, negative 1 for Y, see if it works. Okay. 13. Okay, 13. Complete the table and use the resulting solution points to sketch the graph of the equation. So because it's x to the first and y to the first, the graph is going to be a straight line. So they just want you to plug these in for x, find y when after you plug it in. Plug in 0, plug in 2/3. Gotta love it because when you plug in 2/3, don't panic. 3 times 2/3 minus 2y equals 2. 3 times 2/3, the 3's reduce. Simplify that before you even begin. 2 minus 2y equals 2. Subtract 2. Negative 2y equals 0. Divide by negative 2. And y is equal to 0 when you plug in 2/3. The solution point is the ordered pair. X is 2/3, y is 0. And that would be our x-intercept, sorry, our y-intercept. No, sorry, that's the x-intercept because y is 0, x-intercept. And then plug in the other ones, and it's a straight line, so connect the dots. Now, use a graphing utility to verify the graph. I don't need to see you put anything on your paper for that. That's just a check for you to see if you got it right. Okay, but I don't need to see you actually show me that when you use your calculator to verify. Remember, if I'm going to use my graphing calculator, I cannot type this in. I have to type in what does y equal. So you would have to subtract 3x from both sides. One of the biggest mistakes Algebra 2 students would make when they bring this down, they forget to bring the negative with the 2y. They just write 2y and they don't remember this negative. Keep track of your sums. Negative 2y equals, and I'm trying to rewrite it in slope intercept form, mx plus b. So the x should go next. Negative 3x and then a positive 2. Now, here's where I differ from a lot of former teachers you may have had. Students don't get things correct or they mess up the next step after this. You're supposed to divide by negative 2 when you just divide the whole thing by negative 2. You mess it up. So here's what I try to get my students to do. If I divide one term by negative 2, everybody individually gets divided by a negative 2. That way you can individually see the mx and get your slope and the plus b and get the y-intercept. Negative 3 divided by negative 2, a negative over negative is positive. So this is 3 over 2 times x. And then a positive 2 over a negative 2 is a negative 1. This is what you would type into your calculator. Okay. But doing it that way allows you to visualize and see my mx plus b, my slope of this line is 3 over 2, and my y-intercept is going to be negative 1. That means when x is 0, the answer right here, when I plug in 0 for x, this should be negative 1, and this will be 0 and negative 1 when I plug it in. Okay, 13, and then 17, 22. Matching. So there's really no work you can show with this because it's just matching. I'm not even looking at the graphs. I'm looking at the equations. And then I'll figure out what graph it is. So 17, 2 square root x. And then 18 is an x squared. 19 is another square root x. So I got a couple of square root x's that I can track. Absolute value, that's going to be pretty easy to pick out. And then x cubed and something else. So I got my 2 square roots. Last week, we talked about when you have f of x equal to a square root of x, the graph of square root looks exactly like the radical sine itself. Okay? When it's just a simple square root of an x. Now, this right here resembles the problem that we just did, number 55. When we had to graph a circle, it's not a plus and minus, it's just a plus. But it's an x squared instead of an x, square root of an x squared. And it's minus in it. So square root of an x squared, that's a positive. When I graph the positive part of that, it was the top half of the circle. So now when I look at my graphs, which ones could it be? A square root can look like the top or bottom half of the circle, like this one can, and a square root looks like that one. So how do I know which one? Because they're both looking like square roots. 1 and 0. If you need to check a number, let's just plug in 0. When I plug 0 into this, square root of 0 is 0. 2 times 0. 0, 0. Over here, when I plug in 0, 9 minus 0 squared is just 9. Square root of 9 is 3. 1, 2, 3. This is the picture of this one, because it matches up when I plug in 0. And that's the picture of this one, because when I plug in 0, it's this one. Now, time out. This also has a 0 when you plug in 0, in case you get nervous. But that doesn't look like a square root, number 1. Number 2, check another number. Square root of 4. You know, check a look. Square root of 1. Square root of 1 is 1. 2 times 1 is 2. So if you plug in 1, you should get a 2 out. And this one has that order pair. Over here, when you plug in 1, it's down here at negative. So that can't be. Process of elimination. You're not supposed to graph all of them and see which one matches which. The picture of those. We got done saying last week, x squared and y to the first is a parabola. But oh, x to the first and y squared. That when one of them is squared, they're both parabolas. When it's y minus x squared, that's a parabola that goes up or down. Because it's a negative, it's going to go down. That's the parabola that's going down. And again, let's plug in 0. 4 minus 0 squared is just 4. Okay. Here, we haven't dealt with anything that's y squared and an x itself. But if it's a square, it's a parabola. One of them is squared and the other one is it's parabola. So look what happens. You can't just plug in x, because you would be solving for y squared. I don't want to do that. I'll plug in y. I'm going to let y equals 0. If y is 0, 5 minus 0 squared would be 5. X would be 5. So the ordered pair would be x is 5, y is 0. X is 5, y is, it's a sideways parabola. See, this is the only other possible parabola, but because it's in terms of x equals a y squared, a function of y, they're going to go sideways. Function of x is up and down, function of y is up and right. And because it's a negative y squared, left, if it was a positive y squared, going to the right. Okay. But again, all I did was plug in a number. Okay. Y equals 2. 2 squared is 4. 5 minus 4, 1. Well, that's 5. So it's 1, 2, 3, 4. Oh, y equals 2. Oh, x equals 1. X equals what over here. See, like that's right above the 2. It's not going through 2. It's right here. When y is exactly 2, x is a 1. It's hard to make your brain do the flip. It is. It is. Okay. So that takes care of 17, 19, 18, 22. The last 2 you have. Absolute value is only D shape. Absolute value 0 is 0. 0 minus 3 brings it down 3 units. So this one must be x to the third. We talked about the fundamental theorem of algebra last week. And x to the third would have at most 3 possible solutions, 3 x-intercepts. 1, 2, 3 x-intercepts. Okay. That's my third. Again, you plug in 0, 0 cubed minus 3 times 0, 0, 0. That's all you do. Okay, 23 to 55. And so we're doing every other odd. You're just making a sketch. So 2 minus y squared. So that you can graph it on a calculator, then draw it. So you get an idea of what they start to look like. We're not getting into the specifics of all the pieces, the horizontal shifts, vertical shifts, and everything. You can do it on a calculator and then just copy it down so you can start getting familiar with what the graphs start to look like. So that's through on, so 25, 23, and 29 there. And then we're back to the graphing calculator. 29, we're 30. I want to show you 33. So I can show you how to type in an absolute value code. Here, clear this one out. And clear this one. Y equals the absolute value of x plus 2 minus 3. So the absolute value is right here under math. So you click on math, and you have all of these, functions you can plug in. Right here, if you have a cube root you want to take, or an x root, they're here. A power of 3 x to the third, you can type it right there. Or you can just do it on the front of the calculator. But when you want to do the absolute value, you've got to scroll to the right and get into number theory or numbers. Absolute value, rounding, okay, partial fractions, so all sorts of neat stuff, minimum, that maximum, but absolute value with the parentheses. So absolute value. So absolute value, and I'm going to put in x plus 2. Then I got to close that parentheses, and then a minus 3. Okay. Let me show you something real quick. I want to do a little prediction. So you can see where you're going to be in this one that we talked about. When you start to, what's that?
You use a calculation attached now.
You can use calculator anytime unless I tell you way in advance that you're not going to be able to use it. I will say, show me, tell me, write down what is H, what is K, what is the, vertex. In here, H is -2. K is -3. So the vertex of this absolute value is going to be shifted 2 to the left and then 3 down. The vertex is going to be right here. And then it's going to be here. It's going to be here. It's going to be here. And then here's the nice thing. Absolute value. Parabolas, x squared. They have symmetry. That's the vertex. So what happens on the right-hand side happens on the left of the vertex. So if you go 1 to the right, the y is a -2. If I go 1 to the left right here, now at -3, this will also be -2. When I go 2 to the right, I'm at 0. So when I go 2 to the left, sorry, I'm at -1. When I go 2 to the left, this -4 should be at -1. Which means my graph, when I hit the graph button, is going to end up going right through here.
Does it matter if the one dash is solid?
No, they should be solid. I'm putting a dash because, watch, let's see this. All will be reviewed. I drew a dash so you can see how where I put mine is exactly where they put theirs. I did it for them. And nobody's impressed. Nobody ever was impressed. But I don't need the graphical counter. I know exactly where it is. I know exactly where it's. So that's what you're doing there. Then I'm going to do 45 right now. And I'm only asking you to do 45 because I think it's kind of okay. Makes you think a little bit. So I know it's like, you're supposed to come back to it when you look at the homework. 23 to 55, every other odd, and then come 45. So you do it later, but I'm trying to. Describe the viewing window. In all of the other pictures that they've given us of graphs, they've given us numbers. They put numbers on the windows. This -6 to 6, they've given us an idea what these little notches are, 1, 2, 3, 4. Okay. But on this 45, they're not telling us. We're supposed to figure it out. What we've been doing is checking some numbers. Right here, x is 0. Plug in 0. -10 times 0 is 0. 0 plus 50 is what? Which means the y-intercept would have to be 50 right there. That has to be 50 on the y-axis. Which means, since this notch is divided evenly, this would be what? 20, 25. So on the y-axis, the y-scale is counting by 25. 25, 50, 75, this is 100. Now it's not a perfect, so down here, -25, -50. On the y-axis, the y-min is -50, the y-max is 100. And that's what they want, describe the window. What's the y-min, what's the y-max? Now on the x-axis, we would need to figure out what this is. The x-intercept, if I'm going to figure out what those little notches are, because it's not the scale. These aren't going to be 25 necessarily. So if I let y equals 0, add 10x. 10x is equal to 50, divide by 10. That means x is equal to 5. This right here is exactly 5. Does that look like it's exactly in the middle? Yeah. It is exactly in the middle. So this would be 5, so this is going to be 10. So this right here, 1, 2, 3, 4, 2, 4, 6, 8 to 10. -2, -4, -6, -8, -10. So the x is minimum, the minimum x is -10, x maximum is +10. Okay. 47. So this is, okay. Don't make your brain hurt, but explain how to use a graphing utility to verify that y1 equals y2. So if I was going to use a graphing utility, then I plug this one in for y1, and I plug this one in for y2. And when the first one graphs, the second one would graph right on top of it, and they would be the same graph. That's the only way to prove, using the calculator for graphing, they're the same equation. Algebra concept is being illustrated. Well, take a look. You see up here, we got parentheses, down here we don't. The only way to get rid of the parentheses is because of the distributive property. 1/4 times x squared will be 1/4 x squared. 1/4 times -8. The same one. That's it. Wow. Explain how you would use your graphing utility, graph each one, and they should overlap each other. And then what property is being illustrated? Distributive property. 47, 49, 51. Okay. Now on 51, use graphing utility to graph the equation. Use the trace feature of the graphing utility to approximate the unknown coordinate of each solution point, accurate to 2 decimals. You may need to zoom in. Now, I don't approve necessarily of the trace figure. You actually have access to a better option. So that means what I want to do is I want to show you '51. Oh, that's actually happening further. Yeah. So 51. Square root 5 minus x. Second, square root 5 minus. If I just go to graph, you can see that it's a different picture. The square root is off, opening to the left instead of the right. You do a quick change of zoom here. Because it's negative, so if you put a negative in front of the square root, flips it up and down. If you put a negative inside of the function in front of the x, then it reflects it left and right. And those are things that we'll learn about this chapter later on. What they want to know is, just so you can practice using the calculator, fill in the blank, 3 comma what, and then blank comma 3 using the trace feature. Trace is right here. If you know X, and it's impossible to figure out, and sometimes it will, to figure out the value of what on, using algebra. It's just quicker on a calculator. Instead of using trace, because trace will not always take you to exactly the number you want to plug in. This button right here above the trace, calc in blue. To activate the blue functions, you hit the blue button second. That always activates the functions in blue above. So I'm going to hit second, and then I hit that calc button. And the first option is value. And it's going to evaluate the function at any X coordinate that I plug in. So if I want to know what is that thing equal when X is equal to 3, I hit X equals 3. Tell me what it equals, please. And the answer is 1.4142136. And when you plug in 3, 5 minus 3 is 2, square root of 2. The square root of 2 is 1.414. That's it. That's all you're looking at. But if you had to do something crazy like, if you had to use, okay, let's use trace. You can do trace all you want. Can I land exactly at a 3? Or the wrong way. I can't land exactly at a 3 unless I do some zooming. Okay, hang with me just for another 2 minutes. So that's why you have that exact calc button. If I wanted to do negative 1.783, I can do that. So, negative 1.8763. What's the y value? 2.62227. It tells, and it shows me right there. That's the ordered pair right there. This is my ordered pair. Beats having to plug it in. But how do I do this? Well, now you can't input. When I go to calc, as you can see, it does not let me plug in something for y. It only lets me plug in the independent variable, x. The independent variable is what you get, it's independent, you plug in anything you want, it gets to be anybody you want, you plug in anything you want. The dependent variable depends upon what you just plugged in. You can't change the dependent variable. So now we actually have to be traced. And what you do is you trace along the function until we start going the wrong way. Until we get to a y value that is exactly 3. So it's somewhere in between here and here. So that's when I hit zoom. And I'm going to zoom in, zoom 2. And it wants me, right now it's asking me, where do you want to zoom? And all I got to do is hit enter and it'll zoom in right at that point I'm already at. So then I go back to trace. And I'm watching this one right here. Right now I'm at 3.00. So now I'm going to trace. I need to be smaller than that. So I got to go to the right. So now it's in between here and here. So I would have to zoom in again. So now look, which one is closer? 2.998 or 3.007? So I would zoom in at that point. Zoom, option 2. Hit enter. Trace. I'm smaller than 3, so I'm going to go to the left. Now I'm at 3.000. I can keep on doing this until I can get my y value to be exactly 3 on the right side. And then I know what my x value is. Now you know y is equal to 3 if this is the square root of 9. This would be the square root of 9 if it's 5 minus -4. Look at how close we are. It's not a difficult problem. Okay. Let me just roll through the roll. I don't know names. Bases are hard to pronounce. Okay, so Jose Sam.
Wait, what?
Jose Sam? Okay, so there's 2 Jose's. Okay. William? Okay, so Jose Sam. That's it. That's it. So now you have a lot that you can work on with 1.1. The word problems at the end, there's a little piece, again, it's using a little bit of calculator, that I'll show you that Monday next week. And we'll do 1.2. 1.2 is about linear equations. We actually get back like algebra once.
So ideal is finish the homework on Monday, right?
Well, again, just so you can ask questions, it's not due. So then I'm going to turn it over to you. What do you still need to see that I can help? Okay. That's it. Very good. Have a good weekend. Stay safe. Don't catch anything.